Hey, what's up everybody, and welcome back to the Sanctuary. I'm your host, Professor C, and we are going to do some more A&P. We're going to talk about bones, but finally we have made it out of the skull, so we're going to continue with the axial skeleton by discussing the vertebral column and the spinal curvatures. So, let's go. Okay, the spinal column, or the vertebral column as it can be called as well, is 26 bones that all function in two major ways. One is protecting the spinal cord, of course, because it runs down through the middle of the spinal column. And then secondarily, to transmit weight of the upper body to the legs. Now, that's a human thing because we walk on 2 feet. We are bipedal. Our vertebral column functions way differently than it would in, say, a snake or a dog or a cow even. So all of our vertebrae, as we head down toward the bottom here, as my arrow is showing, are going to get thicker and bigger and more meatier as we get down toward the base of the body. At the top here in blue, I'll put a C. These are in the neck, so we call these cervical vertebrae, and there are 7, C1 to C7. And I'm going to do a separate video on the different types after this one is done. Below that we have the T vertebrae, the thoracic vertebrae, and there are 12 of them named T1 to T12, and all of these will articulate with a pair of ribs, so we would have 24 total ribs. Down below that are what we call the small of the back. We have only 5 vertebrae, L1 to L5 in the lumbar area, but they are big and thick, so they take up a lot more space than, say, the 7 cervicals do. Below that, this kind of arrow-shaped bone that I'm outlining is actually fused bones. There's no cartilage in between them like you see between the other bones in the column. So this is called the sacrum, and it's considered to be one bone only, even though it is a fused section of 5 vertebrae, and they are individually labeled S1 to S5. And down there at the very, very bottom, where it's even hard to point, the little tailbone sticking down there is called the coccyx, and it is variable number in people, but it's usually between 3 and 5 as a number, and they are all fused together as a single unit, and they are not even really bones of the vertebral column like we think about them. They're very rudimentary and don't have much function in the human body, in a modern human body, I should say. Okay. It's necessary in this first introduction to talk about spinal curvatures. Again, if you look at the figure on the left there, you will see that that spinal column is not straight. There are curves to it. They are there to enhance flexibility of the spinal column, which may make sense, especially again since we live in a bipedal existence. The T curve, the thoracic curve, again right here I'll put the T from here to here. Okay, that and the sacral, and I'll put an S down here to remind us there's the sacral curve of the sacrum. Those are obvious at birth. Now the sacral curve, of course, is hidden by a lot of skin and other tissue, and you can't actually see it. But notice here on this baby's back, it kind of looks like it has a turtle's back. It just makes this gently sloping hill here, or this C-shaped spine. And these are called the primary curvatures, the thoracic and the sacral ones. You're born with these. Now, as the baby grows bigger and starts to, say, lift its head, you will acquire a secondary curve. So by lifting your head, the act of doing that and pulling and pulling and pulling the head up, because it's very heavy in a human, this forms the cervical curve, which is up here at the top. And the lumbar curve begins when you start to walk. So you will force the spine into those curves by lifting your head and walking. So these are known as the secondary curvatures. And again, here is the lumbar curvature down here. Now, of course, if there are normal curves, there are abnormal curves or exaggerated curvatures as well. Most folks have heard of scoliosis. That is an exaggerated lateral curvature. That is, the spinal column, like here in this image, is curved out of position. Remember, it's supposed to be nice and straight when you see it in anatomical position from the front or the back. Now, let's say you have an exaggerated lumbar curvature. And you can remember this one because they both start with L, even though that's not the best trick. Lordosis is an exaggerated lumbar curvature. In some vernacular speech, it's referred to as a swayback. Kyphosis, some people pronounce it kyphosis, is a hunchback in vernacular terms. It is an exaggerated thoracic curvature. So this picture right here would be a kyphosis example. Okay, when you talk about the vertebrae, again, you have cervicals and thoracics and lumbars and sacral, and they all look different depending on what part of the spinal column you're in. So I'm going to call this the generic vertebrae. We're going to learn how to spot those and differentiate one from another in the next few talks. But let's look at some general structures so we can know the names of these things as we proceed in other lectures. So the body, I'll put a B here. This big, thick portion of the vertebrae over here on this right-hand image would be this part, looking from the side. Okay, it is basically the part that bears weight. And you could probably have figured that just by knowing about the spinal column already. Now, there are two bridges of bone that are often confused, the pedicle and the lamina. Here, by the body, is a pedicle. There's another one right there. So I'll put a little P here for the two pedicles. The lamina are on the other side here. So there's a lamina, and there's a lamina. So these bridges of bone form this circle in the center. If I change my color here to say yellow, this circle in the center here is formed by those four bridges of bone. It's known as the vertebral foramen. Well, what do you suspect goes through here? Well, the spinal cord will fit through the vertebral foramina. Now, all these vertebral foramina, if you were to put all of these bones together, you'd notice a column or a canal through the column. This is called the vertebral canal. So when you're talking about an individual vertebra like this, the hole in the center is just called vertebral foramen. But if you take all those foramina together and look down the vertebral column, you can see the vertebral canal in all of its form. You can't see the canal looking at just one bone by itself. Now, intervertebral foramina are different. Inter again means in between. So unfortunately, you can only see half of one here, and I'll outline it here in yellow on the bone on the right. This notch there would be the top part of an intervertebral foramen. The rest of it would be part of the bone underneath it like that. Then you have an intervertebral foramen. Now, what sticks out of here? Well, spinal nerves. Those are branches of the spinal cord that come out laterally to head out to the trunk of the body, the arms and the legs, and so forth. A spinous process, and I'll do this on the right-hand image here. There's a spinous process. I'll put SP. Now, depending on the type of vertebrae it is, these can look radically different, and it's one way of telling one vertebra from another is by looking at the spinous process. Because this is sharply angled downward, I can tell very easily this is a thoracic type of vertebra. Now, in the left-hand image, the spinous process is back here by the lamina. Okay, transverse processes would be what you would call the wings, let's say. So here, I'll put a lasso there, and in white on the other side, a lasso there. Those are the transverse processes. And there are some hints, either the angles of them or perhaps some holes drilled in them that you can differentiate the different types. But we're just talking generically now. The wings that stick out the side laterally are called transverse processes. Now this one's tough to see in this image, but I'll change to a blue, and there will be what we call articular facets. A facet is a face, makes sense, and we know what articular means, to touch. So we know there's going to be a vertebrae on top of this and a vertebra underneath this. So we can see the articular facets right here in blue. There's an articular facet. There's an articular facet. Those would be called the superior articular facets. If I look at the bone on the right-hand side if I can look at this intervertebral foramen, or this intervertebral notch that forms that foramen, if there were another bone underneath it, right here would be the inferior articular facet. And here is the superior articular facet. So those are general terms we're going to use when we talk about the vertebrae in the next few talks, when I break them apart into subgroups. All right, I hope you enjoyed that one. Thanks for watching it all the way through. If you did, check out some other videos in the series if you want to learn more about bones or a number of other things we talk about in A&P. Bye-bye.